Hello, everyone, and welcome to the webinar, The Future of Carbon and Building Resilience in a Defossilized World. My name is Chris Robinson. I'm a Senior Director here at Lux Research. I'll be moderating today's session. And presenting today are my colleagues, Kristen Marshall, Associate Research Director, and Mukunda Kaushik, Senior Analyst here at Lux. Throughout the webinar, you can type any questions you have in the questions box on your screen. Time permitting, we'll get to all the questions that we can. But if your question doesn't get answered, please don't hesitate to email it to questions@luxresearchinc.com, and we'll make sure to respond. And lastly, if at any point you experience technical difficulties like a frozen screen, try refreshing your browser and just make sure you have a strong internet connection. And with that, we'll jump into the presentation. Over to you, Kristen and Mukunda.
Great, thanks, Chris. So history is full of stories of evolution, but today we're here to talk about one in particular, and that is the evolution of carbon, and specifically the evolution of carbon away from fossil-based sources. So first, let's look at an example of Nest. For those not familiar, Nest is a Finnish oil refining company that was founded 70 years ago on the basis of securing Finland's oil supply. But in the late 1990s and early 2000s, Nest saw opportunities in renewables emerging from global fears over peak oil. And then in 2006, Nest announced the construction of its first renewable diesel production plant at its Porvoo refinery. This set the company on its transformation from a traditional oil refiner to, in Nest's words, a global leader in renewable and circular solutions. Now, nearly 20 years later, the company has become the biggest renewable diesel producer in the world, investing hundreds of millions of dollars over the years to bring its total production to over 3 million tons of renewable products today. And over the years, the company has expanded beyond fuels, taking advantage of downstream demand for more sustainable and decarbonized products. The company's built a business around renewable hydrocarbons, moving into markets and forming global partnerships that it would have otherwise not likely made as a relatively small Finnish oil refiner. But that's not all. The company has stated even bolder plans for the future, aiming to move into carbon neutral aviation and even end crude oil refining altogether by the mid-2030s. However, despite its successes, the path forward for Nest will not be easy. In fact, the company has faced serious challenges over the past few years due to weaker than expected demand for biofuels and other renewable products. And the company is not alone. Others with renewable businesses are also struggling and have reported losses in recent years. So looking back on Nest's carbon evolution journey, the company started in the 2000s by producing renewable diesel. And in 20 years, it's evolved its renewable hydrocarbons business. But we've seen that things can change quite rapidly given an imbalance between supply and demand. So what does the future hold for Nest? And what will the story for carbon evolution be more broadly? What does this mean for others at the beginning with regards to their carbon evolution journeys? Well, to understand the future of carbon, we have to take a step back to understand what is driving defossilization and the transition away from fossil-based carbon sources. So on the screen, we highlight three major drivers. First, building supply chain resilience. We saw this with Nest and others, especially in the early 2000s, with fears over peak oil. Today, there's growing desire to onshore production of certain products and make use of local resources to do so. Second, the use of renewable material inputs as a means of decarbonizing production, especially for applications where emissions are hard to abate via electrification, like aviation. We're also seeing more downstream brands focus on Scope 3 emissions and looking to suppliers for defossilized products. And lastly, but certainly not least, is waste valorization, with the goal of utilizing waste and recycled material inputs, not just from an environmental standpoint, but a cost standpoint. As waste accumulation bears a cost, there's growing regulations around incorporating more recycled content into products. So for folks on the line today, whether you know it or not, you're on your own carbon evolution journeys. Early pioneers like Nest have shown how taking initiative to switch to renewable carbon sources can bring lots of advantages and new business opportunities. But it's not a risk-free endeavor to go down. And you don't want to get stuck investing in the wrong or short-lived bets. You want to find the future-proof opportunities.
So for the rest of this time, let's jump into the impact of defossilization on industry and also look at how you need to be exploring your different pathways for defossilization. So we'll start by taking the example of someone like the chemicals industry, although the framework that we discussed today does apply to any industry. The chemicals industry today produces a wide range of products, right? So from base chemicals like olefins and aromatics to specialty chemicals like dyes, adhesives, and coatings. Now, the defossilization of the chemicals industry will, of course, impact the chemicals industry, but it'll also have a big impact on upstream and downstream players. Firstly, defossilization will impact the upstream oil and gas industry, which today provides the crude oil and gas feedstock that the chemicals industry uses to make its products. The demand for some of these feedstocks are already facing a decline because of the energy transition. So if the chemicals industry does defossilize and doesn't completely rely on these inputs, what does the oil and gas industry do to avoid losing one of its biggest customers or account for the lost revenue that it gets from the chemicals industry today? Secondly, if the chemicals industry does defossilize, it'll also have an impact on the downstream product producers of these chemicals. So we're talking about electronics, automotives, textiles as some examples. Right, so these industries will essentially have to start paying more for the chemicals and materials that they are buying in a defossilized economy. But let's take a look at the current value chain today, right? So as we look at everything from the feedstock sourcing to the final product. If we assume that the products are not going to change in the near future, that is, the demand for products like methanol, olefins, dyes are not going to disappear. In fact, they might grow, but these products do need to be defossilized. This essentially means that feedstock needs to undergo an evolution. This new feedstock for renewable carbon can come from the oil and gas industry, but it also doesn't have to. So when we think about renewable carbon feedstock, there are three tiers that are being explored today, and they're often viewed in this hierarchy, right? So moving from near term to long term, we start with plastic recycling, where you really embrace circularity and strive to eliminate virgin fossil feedstock. So naturally, the next step is to move from fossil sources, virgin or not, to something that's completely non-fossil, and that's where biomass comes in. But that's more expensive to deploy today. And in the long term, as biomass and recycling face supply chain and availability shortages, we can fill that gap using captured CO2, which is theoretically endless in supply, but extremely expensive to capture and utilize. So for today's presentation, the three types of carbon that you see here will really be the focal point that's really tying all of this together. But while this hierarchy might appear linear, I'm sure most of you in the audience can relate that it's not as easy to adopt. Right? So you can't just start with recycling today, move to biomass in 2030, and then CO2 utilization in 2035. It doesn't really work like that. And that's really because of feedstock, process, product alignment. And this is something that you'll hear us say quite repeatedly through this presentation. We have the three types of feedstock, right? So plastics, biomass, and CO2. We have several processing technology that can be gasification, electrolysis, thermocatalysis, even synbio, and a whole portfolio of carbon-based products that we produce and need. And you can't just pick and choose what you want from each of these three buckets. It doesn't work like that. And this creates a problem for defossilization. So what you need to do is pick one of these three to start, and then tailor the rest around it. You can come at it from the feedstock side, right? So you focus on your source of carbon. For example, you might already be thinking about carbon capture from your own facilities today, and you're looking into options for what to do with that CO2. Is it syngas, methanol, ethylene, maybe even SAF? So from the feedstock side of things, you have options. And for the sake of today's discussion, let's hypothetically assume that you decide that methanol is the best fit for you. So that's great. You have captured CO2. You know you want to convert it into methanol. But in the context of defossilization, that's not the whole picture. And this is what companies need to think about. Because that same methanol can be produced with alternative feedstock. And that's why the product lens, or looking at it from the third bucket that we had, is equally important. Right? So you need to know not just what you want to make, but what is the best and economic way to make that chemical in the timeline that you're operating in. And that's why feedstock process product alignment is so important in defossilization. So let's break that down a bit further, right? So starting with feedstock and process. As you evolve your feedstock, you may have to involve your process as well. And that might involve CapEx for new projects or acquiring new technologies. Let's stay with the example of methanol, which is produced from natural gas today. A very simple near-term solution is to substitute natural gas for biomethane, biogas, or renewable natural gas. In this case, you can stick with your existing reforming assets. But as with most projects today, you don't see this happening. You see more companies using biomass or even CO2 for e-methanol. You can't use reforming for these feedstock. For biomass, you need gasification. For CO2, you need hydrogenation. But luckily, in this example, methanol is compatible with CO2, biogas, biomass, and obviously natural gas, right? So you have a lot of options. But what if you're looking at a product that doesn't have all of these different feedstock options, right? So you can't just convert any feedstock that you have into that product. And that's where it's important to assess feedstock and product alignment. And that's what we're going to be looking at. So what is the compatibility between a feedstock and a product? Because if you don't have this compatible process in the middle, you'll basically be stuck with a lot of carbon that you can't use, which is not very ideal. And of course, with the vast range of carbon-based products that we see today, we've taken the effort to map out key products where we're seeing appreciable amount of work and development based on feedstock conversion to that specific product. So starting from the left, you have recycled plastics. On the top, you have biomass. On the right, you have CO2. Starting from the circumference, right? So you see that there are some products that are exclusive to a specific feedstock. And what you can see here is that there's not too much you can do with just plastics on its own. But with biomass, you get a lot more options to produce products that can't be produced with recycled carbon or CO2. And then when we get to CO2, you have things like formic acid, PLGA through direct or indirect routes. And technically, of course, things like formic acid are natural materials and they're found in nature and can be produced, but we see more activity with using CO2. Then, as we start looking at the intersections, things become a bit more interesting because that's when you have choices. Right? So here you see products that are compatible with 2 out of 3 carbon sources. So you see pyrolysis or catalytic pyrolysis technologies being developed for both plastic waste as well as biomass, occasionally from the same developers as well. There's also a fair amount of overlap between biomass and captured CO2. A lot of it is coming from biological production pathways like alcohols or certain high carbon alcohols that are being developed by companies like LanzaTech. This is an intersection where we do expect to see more activity in the future, specifically as the diversity of CO2 utilization products grow and intersect with the biosphere. Lastly, there's a handful of products that can be produced from all 3 carbon sources. This makes defossilization very challenging because you have a lot more options. So products like oil, syngas, which are very foundational and can be produced for a lot of different downstream products, are compatible with a lot of different carbon sources. This does offer flexibility, but it also creates a challenge of choosing the best option. And that's really what we want to look at today.
Awesome. Yeah. So taking a step back, let's say that your company is looking at different defossilization opportunities. Maybe you want to make use of a given feedstock or a particular product in a defossilized way. How do you assess and compare the different options? Well, at Lux, we've developed a framework for assessing different defossilization options by looking at this feedstock process product alignment. Let's start with product. Here we look to see if there are incentives to produce the product through alternative routes. This is where the underlying drivers of defossilization really fit. With regards to demand, we look to see if the demand for making a defossilized product is strong because of decarbonization or other external drivers. With regards to marketability, we look to see if there is an ability to market that defossilized product and potentially secure a premium for something being bio-based or made from recycled content. Then we consider feedstock. And we consider the feedstock sources that a particular product can be made. The metric we use here is availability. And of course, there will be regional considerations with regards to availability, but at a more general level, we're looking to see if there are still infrastructure and technology advancements needed to be able to tap into a particular feedstock. And then lastly, we look at the process for transforming a particular feedstock to a particular product. Here we consider the resource intensity of the process. This includes additional resource requirements like high energy, electricity requirements, land use requirements, maybe wastewater treatment needs. We also consider the technology maturity. So if the technology has been demonstrated at a commercial scale, and the number of developers, the number of developers working on the technology to reflect momentum. And then lastly, but certainly not least, we look at cost. And if the pathway is more expensive than existing pathways for products on the market, and if those products can be made cost competitively. So let's take a look at this framework in action. And for the sake of time, we're going to jump right into the most complex type of case when you're looking to defossilize a product, but there are multiple competing pathways being developed to arrive at that product. So for this case, we're going to look at different defossilization pathways to ethylene. So in terms of defossilizing ethylene, ethylene is compatible with all three carbon sources. You can make it with advanced plastic recycling, biomass balancing, which is what LyondellBasell is doing, using bio-naphtha from Nest's renewable diesel production, bioethanol dehydration to make 100% bio-based ethylene, which Braskem has done for nearly a decade in Brazil. And then if you have captured CO2, you can convert the CO2 directly to ethylene via electrolysis, which is what early stage startups like CERT are attempting, or even microbially using synthetic biology. Now, if we employ our framework for all of the pathways for ethylene, we start to understand what different defossilization choices entail. And so the results are here on this slide, where we map out all of the pathways and parameters that we mentioned before, with pathways listed vertically and parameters listed horizontally to identify red, which are major challenges, orange, which are moderate challenges, and green, which are lower challenges for each pathway. And I'm not going to go into the specific details for the different pathways for ethylene production. You can get in touch with us after the presentation for that. But we'll rather discuss high-level takeaways from the figure. That's not just for ethylene, but really for any product or system that you're looking to make renewable. So the first thing to consider for the long-term viability of these options is the link between feedstock availability and technology maturity. So for ethylene, we see that pyrolysis of mixed plastic waste has the issue where the technology is mature, but the infrastructure is lacking today, where there's not enough supply of plastic waste to meet the demand for up-and-coming facilities, and the plastic waste feedstocks needed could still be limited in the long term. So the only pathways with abundant feedstock for long-term availability are dehydration, synbio, and electrolysis. And of these three, dehydration has a good balance between feedstock availability and technology maturity. Synbio and electrolysis for ethylene have more major technical challenges to overcome. So if you're thinking long-term, your action items would be to pursue the pathway with high feedstock and tech maturity, or really focus on increasing the tech maturity of the more emerging technologies. However, for the near term, you can also work on unlocking feedstocks and creating near-term opportunities through infrastructure investments that can tap into a given feedstock. So hypothetically, if plastic waste collection and sorting for pyrolysis was better established, you would be able to, or you would be left with a feedstock that's readily available, paired with a process that has high tech maturity. And many pyrolysis developers today are really placing a fair amount of resources into supply chain development. And then, given the cost competitiveness of these pathways, that's going to continue to be a major challenge for adoption. You should explore the link between cost and marketability, where there may be an appetite to pay a premium. So for example, with Braskem's I'm Green polyethylene, it's seen some success in niche product lines, despite being higher cost, because of the marketing story that product manufacturers like Allbirds can sell around the product being bio-based. It's important to emphasize that this, there's less certainty here and real willingness to pay a premium for things like mass balance products, CO2 derived products. And then also marketability is going to depend on the intended end application. For example, sustainability may influence purchasing behavior more for purchasing things like clothing than when purchasing a new car. And then lastly, you may have noticed that demand was consistent across the board and considered a low challenge. However, demand for defossilizing product will depend on how defossilization drivers evolve. Currently, there is a strong interest in decarbonizing ethylene, but what happens if this demand shifts? And that is what happened with Nest. The non-anticipated weak demand for biofuels and other bioproducts, it's what's impacting the company at this point in its carbon evolution journey. These drivers were behind Nest's successes, but also behind the recent decline in sales for Nest. And that brings us to our final section. Yeah, go ahead, Mukunda.
So yeah, here's some final considerations around timing specifically that will help you decide when to engage. And that, as Kristen just mentioned, it largely has to do with a lot of the demand parameters and underlying factors that really drive defossilization. And here's how you can really avoid getting caught in the same trap. Let's come back to Nest for a second, right? So for Nest, the company was smart to have evolved in the near term and ahead of a lot of its competitors by focusing resources where there were strong drivers for defossilization at a time when SAF mandates were put into place, for example. But decisions about the future come down to future demand for defossilized products and the anticipated strength of the first drivers that we discussed. This is the only key to success in your carbon evolution journey, is really aligning yourself with those drivers. And when we think about the strength of demand coming from these drivers, here are three things to really ask yourself. Is there only a weak need to make the product domestically and build supply chain resilience? Or is it really strong and a big need that regulations will strongly favor? Secondly, how strong are the incentives to decarbonize and the other routes to decarbonizing the product that will impact a specific pathway, right? So for example, when we talk to a lot of the bigger chemical companies, where a majority of the emissions are scope 3, there is less of a concern today around decarbonization, right? So how does that fit in? And lastly, are circular policies unreliable or subject to change, right? So how do regulations really view a lot of these feedstock? This applies more to pyrolysis and how countries in specific regions are being precautious about whether the process is considered recycling. So that can have a big impact. So when it comes to defossilization and the evolution of carbon, first, understanding feedstock process product alignment is really critical, right? So not every product can be made from every feedstock, and not every product is actually worth being made from a defossilized route. And while companies focus a lot on quantifying their emissions, it's equally important to be able to quantify your actual carbon use and how much carbon do you demand as a business. In the near term, there will be opportunities to exploit the marketability of products. So splitting demand and marketability and treating them as separate variables is important. But for the long term, it's really understanding the strength of those three drivers and the dynamics around them. And lastly, as we saw, consider infrastructure investment today that could unlock pathways to defossilize and make carbon sources more available. And so I think it's examples like ExxonMobil, for example, investing in advanced recycling are great examples of that, or as Kristen spoke about earlier with ethylene. So value chain developments can really help unlock that feedstock. And with that, thank you so much for your time today, and we'll answer any questions.
Yeah, thank you very much, both Kristen and Mukunda. So we'll now be taking questions you might have in the presentation. As a reminder, you can drop those into the Q&A box, and I already see at least one coming in now as well. So keep entering your questions, and if we don't get to your questions, we'll be in touch after the webinar. The question that we have coming in we used ethylene as an example for showing the framework in action. But what if I don't have the specific end product in mind? So how would you evaluate the different opportunities if I was starting with CO2 or sugar, for example?
Yeah, I can start with this one. So, just because you can make something renewable doesn't mean that you should or that it's a good opportunity. We've seen this with the failings of the bio-based chemical space, for example, when you had companies looking to scale the production of things like succinic acid without understanding or taking the time to develop the market. So here, really, to avoid getting into trouble, you have to look and really examine the demand and marketability parameters that we mentioned before. So what are the defossilization drivers or other market drivers incentivizing an alternative? And are they strong? You can see this in action with policies playing out worldwide around bioplastics, for example, right? Where in Southeast Asia, India, there's, with the way that the single-use plastics regulations are shaping up, they're incentivizing alternatives like PLA. In Europe, on the other hand, with Europe's single-use plastics directive, they're not as favorable around bioplastics. And so we've seen, companies once planning to build up capacity there for PLA halt those plans. So really important to look at the underlying defossilization drivers. And then after you've come across some products that might be interesting, you also have to remember to look at, are there other competing routes to make those products in a renewable way? So that's the second important thing not to forget.
Yeah, and if you have a certain feedstock in mind that you're already working with, that can be lignin from a byproduct, or it can be CO2. Coming back to that Venn diagram that we looked at is a good place to start, because it helps you map out what is theoretically possible from that feedstock, right? And then it'll be about aligning that product to your business.
Excellent. I think we have time for one more question, and this is not a technical one, but one related to policy. So which policies are having the most direct impact on defossilization momentum today?
Kristen, maybe you want to start?
Oh, yeah. Well, at least I can speak from a chemicals point of view. I think that the policies having most of an impact are, ones like plastic content mandates, so regulations actually requiring recycled content in end products, creating that demand. Also bans and restrictions on plastics and certain chemicals, creating opportunities for alternatives. So I mentioned single-use plastics directive before. You can look at some of the restrictions around substances of high concern that are creating those opportunities for alternative chemicals. I think in terms of, if the regulations we're looking for to have more widespread support for bio-based or renewable chemicals would be more tax incentives and subsidies. We see those more in Southeast Asia, Asia Pacific, than we are seeing in Europe and the Americas in terms of supporting these renewable products. But I would say that those are some of the regulations that we continue to monitor.
Yep. And then I think it's also a question of what different regulators considered accepted versus non-accepted that will impact whether you're able to make a specific product or not. The other thing that we didn't get into too much today is also, if you look at the chemicals that we're looking to defossilize, what if technology develops to a point where you don't need to produce those intermediates anymore because we find a better way to actually get to their derivatives and their final use cases, right? So if that's the case, you don't necessarily have to defossilize the product because you may not need that product because there's a cheaper and a better way to get to that final use case. And at least in the long-term, regulations can also impact that.
Excellent. Well, I want to thank everyone for their time today, and thank you to Kristen and Mukunda. And that concludes our webinar. So the slide presentation and recording from this webinar will be sent to all attendees via email later today. After leaving, you'll be prompted to complete a short survey in today's presentation. We do appreciate any feedback you might have. It helps us inform and kind of improve future webinars. So take a moment, check out upcoming webinars on our website, And thank you for joining us. Have a great day.